Let's continue now to talk about some word problems. So in the equation, p of x equals negative x squared plus 140x plus 10, this models the number of people infected x days after an epidemic outbreak. So we see here that x is the number of days, and they're telling us that p of x is the number of people that are infected. That's why they're using p for people. Okay, name the units for the x-axis. So if we look down at our graph, we're going to be graphing this. It just told us what x represented. So what would be the units? Number of days, right? And then what will the y-axis measure? Yeah, people infected. And so you could actually even write that on your graph. Here on the x-axis, you have days, and then over here you have people infected. Okay, with the virus. Oops, I keep going off the page there. Okay, so how many people will be infected, after 30 days? Interpret your results in a complete sentence. Part of the reason why I'm reading these directions for you is I had a student once miss like 3 points on his test, and it was all because he didn't write his answers in a complete sentence. So he was very mad about that. So I thought I would tell you all so that you don't make that same mistake. But how would we figure out if we know that it's day 30, we want to know how many people are infected? Where would we put that 30? Yes, because that's the number of days. So we're going to find P of 30 equals negative 30 squared plus 140 times 30 plus 10. Now notice that negative is outside of the parentheses. That's because we're not squaring the negative from the original equation. Okay, so I'm going to use the calculator because it's easier. So negative 30 squared. And notice that negative is not in parentheses, so it's going to keep it negative. Plus 140 times 30 plus 10 equals, okay, and then we need to take that number and interpret it in a complete sentence. So what would be your complete sentence answer? After 30 days, 3,310 people are infected. Perfect. Okay, algebraically. Now, whenever you see that word algebraically, it means I want to see some algebra. So even though I'm showing you all of these fancy tricks with the calculator, I still do want you to show your work, right? And I still do want you to do it algebraically because the calculator is there to help us check. Determine how many days after the outbreak the maximum number of people are sick. When you see this word maximum, what does it code for? It's the vertex. And why is the vertex? Look at the equation and tell me, why is the vertex going to be the maximum point? Because, yes, it starts with a negative. That means my parabola opens downward. Okay, I want to find the vertex, so I have to first start by going x equals negative b over 2a. If we go back here, we know that a is equal to negative 1, b is equal to 140, and c is equal to 10. Which, by the way, c equals 10 means that how many people were originally infected with this virus? 10 people, because on day 0, right? Day 0, that's our y-intercept. Totally non-consequential here, but anyway, I just got off track on that. Okay, so what am I going to plug in then? Negative 140 over 2 times negative 1. You see where I'm getting the negative 1 from? Negative divided by a negative is a positive. We have 140 divided by 2, which is equal to 70. So that means what? If we're going to interpret, what does that mean? The maximum, how many days after the outbreak was the maximum number of people sick? You would say to that answer, after 70 days, the maximum number of, well, whatever. After 70 days, the maximum number of people are infected. But we don't know how many people, right? What is the maximum number of people infected? How do we find that after we know? Oh, yes, just the same way we did here before. So we're going to find P of 70 equals negative 70 squared plus 140 times 70 plus 10. So I'm going to plug that again into my calculator. Negative 70 squared, because that negative is not in parentheses, it's not going to square the negative, plus 140 times 70 plus 10, and we have 4,910 equals 4,910. So if we go over here to 70, here I'm counting 10, 20, 30, 40, 50. That means I'm using a scale of 50. Here's 70, and now notice I'm actually drawing, when I draw x equals 70, I'm drawing it as a dotted line and not a solid line because it's not actually part of the graph. It's just the imaginary line that is dividing the parabola in half, okay? And then up here we have 4,900 people are infected. And so I could kind of estimate that's a little bit less than 5,000. And so far we kind of are seeing this parabola shape. Draw the graph of the function, label the information you found in part A, B, C, and D. So right here, this is our vertex at 70, comma, 4, 9, 10. Okay. And then we know we were talking about the y-intercept. We didn't really talk about the x-intercept, and we didn't find it. So I actually kind of want to show you how you can get some more points from the graph. If I go to y equals and I clear out what I have, I can type in the new equation, which is negative, and be sure to use the negative sign, not the subtract. Okay, the negative is at the very bottom. Maybe I need to zoom out a little bit. I can't really right now. Okay, so negative x squared plus 140x plus 10, right? That's the equation. And if I press graph, notice how I'm not really seeing the graph. I want to see this nice, neat parabola. Well, we were talking about before how to set up the window. So if you want to change the window, what button do you think you should push? Window, brilliant. Okay, now I was talking about how this is a standard viewing window, but we want to be able to see, here's our x minimum, here's our x maximum. So our x minimum, we probably could leave it at negative 10, or we could change it to 0. It doesn't really matter, it's just a little bit over here. What should our x maximum be? At least what? Yeah, and actually, even if I want to use this graph, the graph, it looks like, is even going to maybe even, 200, 150 maybe. It doesn't matter. You want to be a little over because you want to be able to see all of it, okay? So 150 looks good. And then what about y minimum? What's the y minimum here? Yeah, or negative 500. And then y maximum would be all the way up here, y maximum. And let's try 6,000, right? And now if we press graph, and actually the scale doesn't matter, but you could even notice you're counting by 500. You could change the scale, y scale, to 500 if you want. Otherwise, it's going to be a dark line. That's where you're seeing, that's a scale of 1 at the bottom. Okay, so now you can see the nice, neat parabola. And some of the features, remember, if we want to find the vertex and the intercepts, maybe we want to know how many days does it take before the outbreak is nobody else is infected, right? No, 0 people are infected at a certain time. So I'm going to show you 2 different things. How we can check the vertex. We go second trace takes us to a calculate menu. Which one of these is going to help me find the vertex? Maximum, exactly. So if I go to maximum, I can press enter. I want to be on the left-hand side. Am I on the left-hand side of the maximum? I press enter. I'm going to scroll past the maximum to go on the right-hand side. Doesn't matter where on the right, you just push enter when you get over to the right, and then guess, push enter one more time. There's the maximum. You see it's 70. It has some other decimal points. That's just a little calculator glitch. And then you see the y-coordinate is the 4910. Okay, so that's how we find the maximum. What if I want to find this? This is actually, this x-intercept is also known as a zero of the function. So let's go back to calculate. I want to find the zero. Okay, so I go down to 2, I press enter, and then I want to be on the left-hand side of that 0. So am I on the left-hand side reading left to right? Yes, I am. I push enter. Now I need to go past it to the right. I'm scrolling over to the right. Am I to the right of it? Well, you don't see it anymore, but yes, enter. And then when you see guess, you just push enter one more time. There's the 0 is at 140, approximately around, we'll round it off. So 110, 20, 30, 40. So 140 days is when that, and then if I wanted to find the other 0, I would have to do that same procedure again on the other side, okay? So essentially we see this. Now I could just draw it up and down, or to make it more accurate, you can go to your table of values and you could just start plotting some of these points. 1, 149, you know, maybe you take, I don't know, 50. But anyway, for now, I'm just going to draw a little sketch of the parabola, but I would like you to practice using the table of values, but just in the interest of time, I'm not going to plot some of those points, but you can look at the points that you have there, and you can just find some convenient points to plot. Does that kind of make sense? Any questions about using the graphing calculator to help you graph? Okay, we'll stop this one.